Hi, everybody. Welcome back to the lecture video. And believe it or not, this is the last section for this semester here. And we're going to talk about very, very important functions. We call these logarithm functions here. So before we start, and so let me see here. Let's try to define what is log functions here. The log functions, if you still remember, in the section 10.4, we talk about the exponential function. So the log function and the exponential functions, they are really is the inverse for each other. So they can change the way how they write. Okay, so let's take a look at the definition. Then we're going to do many practice for that. And so we know, like, for any a greater than 0 here, and a cannot be equal to 1, and x need to be greater than 0 because that's the log function's domains here. So the way we define the log function y is equal to the log a to the x here. All right, so the a's here, this is what we call is the base for this log function. And this log function, like we said, the log function is really the inverse of the, is the inverse of the exponential. So the log and the exponential can be rewrite to each other. So if I write like y equal to the log ax, I can rewrite this as a to the y equal to x, right? As you see, the a still is the base for my exponential functions here, okay? So now let's just, based on this definitions here, let's try to do some example. So first is let's make sure we know how to go back and forth, right? Okay, so now let's take a look here. I want to rewrite, okay, write into the log function. So the first example say, if you give me an exponential, so I want to write into the log functions here. Okay, so let's take a look at these examples here. So for example, we have a 4 to the 5th. Everybody know 4 to the 5th. If you put it into the calculator, it will give you 1024, right? So now I know the base here. This is what? This is my A value. And what is here? The 1024, that is what? That is my X value. And then in here, the 5, what is this one's here? The 5 is my Y values here, right? So now I can just rewrite it. So how do I rewrite it? We said Y, that means 5, is equal to log base 4, 1024. So as long as you know this definition, you'll be able to rewrite it. Okay, so now let's take a look at the number 2's here. So if I have 5 to the negative 3 is equal to 1 over 125 here, okay? So now let's take a look again, see how do we do that. So first things you identify, this is your base, right? So this is the base A. And then what is your X here? This is your X here, right? Then what is your Y's here? This is your Y's here. So now I can rewrite it. So how do I rewrite it? So now rewrite it is negative 3 is equal to the log base of what? Base of the 5, then the 125 here, right? So it's a pretty straightforward. Okay, so now let's take a look at other examples here. Let's do the backward here, right? So if I give you, So let's write into exponential. Okay, so let's take a look at the first examples here. So if I have 4 is equal to log 4, 2, 5, 6. Okay, so now I need to write it into, the exponential. So first, let's identify the base. So this is what? This is my base is here, right? So what is my x here? This is my x. And what is my y's here? This is my y's here, right? Okay, so now I know the a, x, and y. So I can rewrite it. So I will say 4 to the 4th is equal to 2, 5, 6 here, right? So that's pretty cool, right? Okay, so now let's take a look at the other ones here. So problem number 2 here, if I have a negative 3 is equal to the log 2, 1, 8. So let's see how do we rewrite it. Okay, so to rewrite this ones here, all right? So you say, okay, let's still identify each number. So this is my A, right? This is my base A. And what is here? This is my X, right? And what is here? This is my Y here. So now you can rewrite it to the A, so it's 2 to the y, negative 3, is equal to what? Is equal to x is 1 over 8. Okay, so this is what we call it, how is the log function and related to the exponentials here, right? Okay, so now we know the a is, we call it the base, right? So the most important part is a is the base. So if you take a look at your calculator, and most of the calculator, they will have like 2 keys here. One is they put a log, and one is ln key. Okay, so those are the 2 keys in your calculator. What are those things? Okay, so now in here, we're going to talk about the 2 special type of the log here. Okay, so the first ones here, the first log we call it is the common log. Okay, common log has a very special value. That means your base is specifically is log 10 here, right? That's what we call it, the common log here. And so that's why we call it the common log. So the way because it is a common log, so the way we write it as the log. So we don't put any bases here. So like when you see your calculator, if you hit the log key, LOG key, that means it's a common log. That means the base is equal to 10 here, right? Then the next thing here is you're going to use very, very commonly used in the older math. We call it is what? We call it is natural log. Okay, so the natural log have one very, very specific base value also. So the natural log A is equal to a very special value, is to the e's here. Remember the e is this irrational number, 2.7182 something there. Okay, so for the way we write the natural log, we don't write the base neither. We have a special symbol, we call it ln's here. So when you see the calculator, they have the ln's here, right? And then you will know that is dealing with the natural log here, okay? So then the next questions here, you will ask, you say, how about Well, if my calculator only have these two functions here, log and natural log. So how about if I want to find something? Okay, so if how about if I want to find the log 3, like 19. So you say, well, if I want to use my calculator to find the log 3, 19, that means this log functions with base 3 and 19. How I'm going to do it by using my, my calculators here. So why the calculator only lists the 2 special log? So how can I find the general log functions here? So that's what is the next things we talk about. We call this the change base. Okay, so that's why. So if you give me, so we said if you give me any log functions here. So if you said a log, you give me anything here, a to the x here. I can always find it by using the calculator. What does that mean? That means these ones here, you can change to the any way you want. So you can change to the, so you can change, we call it this is, so you can change it to any base you want, to the bx and the log to the b to the a. So that's what they tell you. They say, hey, you can change it to the any bases here. So now that's why by using the calculator, okay, so by using the calculator, because the calculator only give us the log and the natural log, so you can change that to, so you can say, hey, I can just use the log x over log a here. So remember here, I don't have any base here. That means you just use a common log. Or this value also be equal to the natural log x, natural log a. Is that amazing? So like for examples here, right? So like the example we did, we say, hey, I want to use the calculator to find the log 3, the 19. Then how did you find it? Well, you can just use you can either use the log 19, or you can use the log 3, or you can use the natural log 19 and the natural log 3. See here, that will give you the same value. So that is pretty cool, right? Okay, so now based on this here, let me, so let's take a look, right? So if I want to find the values here, okay, so like here, if I do the log, okay, so it's a pointer 0001, right? So I want to see what is the value of this. Of course, you can put it into the calculator, but now if they tell you don't use the calculator, then you will say, okay, this is the one. This is really is the base 10, right? I just don't write it because if the base 10, we just write as log. So in here, you will say this is a log. Really, the base is the base 10. And then the pointer 0001, right? So that is what? That is 1 over 10 to the 4th power, right? So 1 over 10 to the 4th powers here. So remember okay, so from the previous our log definitions, right? Y equal to the log AX. Let me write here again. Y equal to the log AX is equivalent to X equal to the AYs here. So I'm going to find what is the value of this, right? So I will say, okay, I'm going to find what is the value of this. So then I know what is the values here. I said, okay, based on this relation, I know this is 1 over 10 to the 4th power Okay, so this is 1 over 10 to the fourth power is equal to what? Is the 10 to the what? Is 10 to the y, right? So this is the y value I'm looking for, right? So this is the y value I'm looking for. So it's 10 to the y. So now you can see here 10 to the 4 is 10 to the negative 4 equal to the 10 to the y. And because they have the same base, so that's why y equal to negative 4. So that's how do I get these values here? So I will say this one is equal to the negative 4 here. All right. And now let's take a look at a few other examples here, right? So here, by just using the relations here. So like I have a log, right, 2 to the 16. So what is this equal to? This equal to y. So I know the 16 is equal to 2 to the y. So what is the 16? 2 to the 4, okay? 2 to the 4 equal to 2 to the y. So then the base and the base cancel. So that's why what you have here. So y is equal to what? Y is equal to 4, right? Okay, so now let's take a look at another examples here. So this one's here, this one is another example. So these examples here will be log 4, 1 of the 256. What is this one going to equal to? Okay, so you will say, all right, 1 over 256 is equal to the 4 to the y. The 256, it will be, okay, so here, the 256 will be, you rewrite it, this is 4 to the fourth power equal to the 4 to the y. So this is a 4 to the negative 4, so 4 to the y. And then you, because the base is the same, so that's why you get to the y equal to the negative 4. So that's how do you get a y equal to, so the whole thing's here is equal to the negative 4 here, right? Okay, so one more problem here. Let's take a look. This one is pretty cool. Okay, so this one's here. Okay, so I want to find the natural log e to the 9. All right. So while you see the natural logs, right? So I want to see what is the y's here. So you say, hey, natural log really is log, right? So it's a log with a very special base e, right? To the e to the 9th here. Okay, so equal to y. So now you put these ones here. So you say the E9 is equal to EY. So based on the, based on whatever so based on the things we did from the, from the definitions, right? Okay, so now you will see here, boom, boom, E cancels, right? So 9 equal to the Y. So I know this value equal to the 9 here. So this come out with very good properties here. So because we say the natural log and exponential kind of like the inverse is like inverse functions, right? So whenever they bump into each other, you can directly cancel it. So like this one, natural log and e. So they bump to each other. So these two just cancel, will just become e's here. So it's just like in here. So if I have a log 10 to the y, 10 to the, let's say here, I have a log 10 to the 2k, right? So in here, remember we say if a log without a base, it's a common log. So basically, it's a base 10 here. So remember we said, oh, here, if they match the base, so basically you can cancel that out. So the answers here will be like 2Ks here. Okay, and so now that's that's about the how to change the log and the exponential back and forth. Then the next things here we're going to talk about is several very good properties. You might want to remember this, right? Or put it into like the formula sheets, right? So it will be easy for you. So this is the several good properties here. Okay, so the first property here is the log. If two log functions, be careful here, if two log functions here, if they have the same base, like this log is A, this log is A. So when you add these two log functions, it will be equal to, you just multiply it with the same base, right? And the second one here is if you have log ax minus log b, log ay. So still the underlying assumption is if you have the same base, right? Then if you minus two log function is log a x divided by y here, all right? Then the third ones here we talk about is like if you have log a x to the r's powers, right? So if you have exponents inside here, so basically tell you, you can move this exponent to the front. So this will be the log a to the x here, okay? And then we have a special things here. So the log for any base, if here is 1, the log function is equal to 0, all right? And also, like we talk about, if this is the log functions with base A and you have exponents here, is equal to the base here, right? So if this is the base A, this is the base A, so it's similar, like you can, because they are kind of the inverse function, you can just cancel that. So it's simple, just cancel out, right? So like the special, the special case, right? We just talk about. So if the log 10, because log 10 is, here's the base 10, so it's 1. So it's just like the natural log 1, natural log e is 1. The reason why is because this is like a power 1, this is the power 1. And then this, the base here, this is a 10. They just not write it, and then the base here is e, right? So that's the special cases here. Okay, so now let's take a look at some examples here. And okay, so we want to use the log property to rewrite, okay? So like a rewrite, simplify. So this one's here is we want to simplify. Okay, so now let's take a look here, log 5. Okay, so 5p, okay, ak. Okay, so first I'm using, okay, so be careful here, right? So this is like a plus, you times, minus, you divide, right? Okay, so here, let's take a look. First things I see, oh, let's divide 5p over ak. So I know I can separate that out, become the 5p minus 5ak. Right, because using the property tools, right? The property, well, maybe I put this 1, 2, 3, 4 is better. Okay, so this one's here, I will set a number 1 property, number 2 property, number 3 property, number 4 property, number 5 property. So I said use property number 2. Now you see, oh, I see something. The inside here is 5 times P. This is A times K. So I can use the property number 1. So this is be log 5 plus log 5 P minus log 5 A plus log 5 K is here, right? Then you say, oh, I spot something. This one's here, log 5 is here. I can use what? I can use property number 5. So this one will give you 1 plus log 5P minus log 5A minus log 5K. That's what is the problem says, simplify to the lowest terms here. Okay, now let's try to take a look at another example. Now I think it should be fine with to take a, okay, so let's take a look at this one here. Okay, so this one is, so I have a natural log. Okay, so this is 3 times square roots of the 2. Then the bottom here, this is the 7 with the cube roots. Okay, so don't get scared by the natural log. The natural log is just a special log. So you say, oh, I see, it's divide. So you use property number 2. So this will be the 3 square roots of the 2 minus natural log 7 to the cube roots, right? So this is the property number 2. Divide is minus. Oh, now you see something special here. You say, hey, this is multiplication. Okay, so I use property number 1. So this is natural log 3 plus the natural log square roots of the 2 minus natural log 7 to the cube, right? So I use property number 1 here to separate the multiplication to add. Now I can still simplify a little bit. Square roots of the 2 is 2 to the 1/2, right? And the square roots, cube roots of the 7 is 7 to the 1 cube. Then I can use property number 3. I can move those exponents to the front here. So that will give me the answer is natural log 3 plus 1/2 natural log 2 minus 1/3 natural log 7. So this is by the property what? Property number 3 is here. So this will be your final answer by using those properties here, all right? So far so good? All right. And I guess one more, and then we will call it quit. And then for the remaining, we're going to put into the next part 2, how to solve the log function equations here. So this last example is also going to use the properties, right? So the example tell you, so they said, suppose log base B 2 equal to A, and the log base B 3 is equal to C. Okay, so I want to find, first let's see here. I want to find number 1, log base B, the 16. All right, so the number 2, I'm going to find the log base B, the 12. Let's see what is the value. You say, oh my gosh, this is A and C, right? So I don't have the value. I cannot plug into the calculator. So let's take a look. This is log B. 16 is what? 16 is 2 to the 4th power, right? And now I can use the property number 3 to move this 4 to the front. So this is 4 times log base b, the 2. And I know the log base b, the 2 is equal to a. So what is here? This answer is 4a. All right. So now let's take a look at log base 12. Log base 12 will be, well, it's 4 times 3, right? Then I can use the log property. Multiplication is add. So I will log b to the 4 plus log b to the 3. Then the 4, I can change it to the b to the 2 to the square plus log b to the 3. Now, the same thing, I can use the property number 3 to move this one to the front. So it's log b to the 2 plus log b to the 3. But here, this one's here is A, and this one's here is C. So what is my final answer? Is the 2A plus C. Right? So that's how do we use the log properties here, right? So from here to here, this is the what? This is the property. Number 1, multiplication is add. Then from here to here, this is the property. What? Property number 3, you take the exponents, then you can move the exponent to the front, right? So this is the same way as here. This is the property number 3, right? So those properties are super important properties here. So make sure you are very familiar with this. And then our next lecture video we are going to talk about is how to solve the logarithm equations. That would be fun here, right? So right now I think it's a good time to stop and you'll be able to review it and then before you go to the next videos, right? Okay, it's like nice to talk to you. Can't believe we almost end this semesters here and you guys doing great. So keep up with the good work, all right?